this video, I'm going to be talking about a vitamin D in context with the toll-like receptor 4, which is activated by lipopolysaccharides, or LPS in short, which is triggered by gluten ingestion. Now, before I go on, make sure to like and share these videos with your friends and family and anyone else, as many people as possible, to help push out these videos to a wider audience so that they know the missing pieces and missing links within biochemistry and cancer and immune system that possibly the other YouTube influencer and health community channels are actually leaving out of their own videos. So I think that these pieces that I'm adding are very important and that people should know these missing links so that they can help improve their own health. Okay, so there is the toll-like receptor 4 and LPS, or short for lipopolysaccharides, which is a gram-negative bacteria that leaks out during leaky gut situations, also possibly because of weak tight junction proteins, including Claudin, which I've talked about in other videos. But in this case, toll-like receptor 4 activation triggers pro-inflammatory cytokines such as TNF-α, interleukin-1 beta, and interleukin-6. Okay, now boosting TNF-α could actually be a good thing because if TNF-α becomes too low, that could actually lead to a vitamin D deficiency, which I've actually already explained in some of my other videos. But the bad thing about toll-like receptor 4 activation by lipopolysaccharides, and I've pointed this out in other videos, is that it also increases interleukin-6. The problem with interleukin-6 is that it increases hepcidin. Hepcidin degrades ferroportin, therefore iron gets trapped in macrophages, leading to an iron deficiency. Because the ferroportin is supposed to export the iron out of the macrophages. But of course, the iron gets trapped if hepcidin is degrading the ferroportin. Okay, so vitamin D metabolism occurs in mainly two steps, which is in the liver with 25-OHD or calcidiol, and also in the kidneys with 125-OH2D calcitriol, which is the active form from the kidneys. And the enzyme involved is the CYP27B1 enzyme. So that converts the vitamin D to its active form in the kidney. Okay, there is an enzyme that catabolizes vitamin D or degrades active vitamin D, and that catabolic enzyme is called CYP24A1. Okay, so here's a huge problem with gluten ingestion, like found in many foods such as wheat, grains. A lot of breads have gluten, pizza has gluten, possibly a lot of other foods, even rice has gluten. So if you keep an eye on the ingredients list on the foods you buy, that if gluten is one of the first ingredients on the list, or at least closer to the top of the list, then that food has a lot of gluten. And the reason to avoid gluten is because gluten increases lipopolysaccharides in the gut. So chronic or excessive LPS exposure, or short for lipopolysaccharides, can induce the catabolic enzyme CYP24A1, increasing vitamin D catabolism or increasing the degradation of vitamin D, therefore leading to vitamin D deficiency. Also, persistent inflammation, possibly because of gluten, may lead to functional vitamin D deficiency despite normal 25-OHD levels. So vitamin D deficiency itself increases inflammation. So to create a negative feedback loop, because if there's inflammation because of no vitamin D, then the inflammation is going to persist, therefore lowering the vitamin D even more and then creating even more inflammation. So gluten ingestion, especially chronically, can not only create vitamin D deficiencies, but it could also possibly lead to autoimmunity as well. And this is because if gluten ingestion triggers LPS, and then toll-like receptor 4 recognizes the LPS, because recognizing or dealing with lipopolysaccharides is one of toll-like receptor 4's main functions. Um, as a result of the activation of the TLR4 by LPS, it recruits immune cells to infection sites, such as neutrophils, macrophages, and including T cells. Okay, now the problem with excessive T cells, which could be the result of chronic gluten over a long period of time, is that it can indeed lead to autoimmunity, which is the healthy body tissues being attacked by T cells. So if there are too many T cells or excessive T cells, because of the constant toll-like receptor 4 activation by gluten ingestion, then that could potentially lead to healthy tissue being attacked because there are way too many T cells. That's why it's important to check the ingredients list on the foods that you buy in the grocery store to make sure that there isn't gluten, or at least to make the gluten at the bottom of the list of the total number of ingredients and not at the top of the list. Because if it's at the top, then that means that that particular food has a lot of gluten. Okay, so quick recap. LPS, short for lipopolysaccharides, triggers toll-like receptor 4. The TLR4, one of its main functions is to deal with gram-negative bacteria such as LPS. This activation triggers TNF-alpha, which could be good to because if TNF-alpha is too low, then that leads to a vitamin D deficiency. Also, toll-like receptor 4 activation triggers interleukin-6, which could lead to iron trapped in macrophages, leading to iron deficiency. Vitamin D metabolism occurs either in the liver with 25-OHD, calcidiol, and then also in the kidney. The kidney activates vitamin D to its active form, calcitriol. Okay, the enzyme that degrades or catabolizes vitamin D is CYP24A1. Chronic or excessive LPS or lipopolysaccharide exposure as a result of gluten ingestion can lead to the increase of that catabolic enzyme CYP24A1, leading to vitamin D deficiency. So that's it for the video. If you're interested in more future videos, then make sure to like, comment, share, keep it locked in here on my channel, and I'll see you in the next video.